is random numbers. Now, a lot of times in programming, you'll want to give a sense of unpredictability in your program. In a game, that might be a sudden change in your computer opponent's strategy. In other types of programs, you might need to generate a random key to match an encryption algorithm. C++ gives us a way to do that using the rand function. To demonstrate this, we're going to create a die rolling program. This will simulate the roll of a six-sided die like you'd see in a game of craps or Monopoly or Yahtzee or any of those games. The computer will calculate the roll by generating a random number. So let's see how that works. We've got a new text document, and I'm going to save that as dieroller.cpp. Put my comments at the top. And I'll go ahead and start my include. I'm including IOStream, as usual. I'm including a couple other libraries as well. First up is cstdlib. This file contains a whole bunch of stuff, including functions that deal with generating random numbers. The rand function, which we'll call in a minute, is in that library along with several other functions. We're also going to include the ctime library because that will give us access to the time function, which we'll also use. Now we'll declare that we're using the std namespace, and we can begin our main int, our main function. First thing we do is srand static cast unsigned int time zero. And I'm putting a comment here that this seeds our random number generator. Now, the way a computer generates these random numbers, they're really pseudo-random numbers based on a formula. It's like the computer has a giant book of predetermined numbers in a random sequence. And it just reads the number from the book. The problem is, the computer will always start reading the book from the beginning. So if you don't find a way to work around it, then the computer will always generate the same series of quote-unquote random numbers in a program. And this usually isn't what you want. To get around this, we tell the computer to start reading from some arbitrary place in the book at the time that the program begins. This is called seeding the random number generator. That's what we do in this line. In the srand line, we pass as an unsigned integer a number based on the current time, and that tells the computer, that tells the random number generator where in the book it should start reading. Okay. The intricate details of this aren't really important. What's really important is to just know that this line of code will seed your random number generator so that the numbers that it generates will be as random as we can get with the computer. Every time the program runs, it will start at a different place in the book. Now, if you were able to run this program at the exact same time on two different computers, and I'm talking down to the nanosecond, you might see duplicate random number sequences. But generally that doesn't usually happen. Okay, now we're going to create an integer called random number, and we're going to declare that that variable as an int called random number, and we're going to set it equal to rand, open parentheses, close parentheses, which will generate a random number. And we've already seeded our random number generator, so it will be it should be a truly random number. Now I'm going to create a new variable called die. This is going to be our dice. And I want this to be a value between 1 and 6. The rand function will generate a number between 0 and 32,767. Some compilers might go higher, but 32,767 is the default. So we want to take that random number and somehow get a value between 1 and 6. The way we do that is using division. So we're going to take random number, and we're going to use our modulus operator, 6. So what will happen here is the computer will generate the random number, then it will divide it by 6, and return the modulus, the remainder that's left over. Anytime you're dividing any positive number by 6, you're going to get a value, you're going to get a remainder between 0 and 5. That's just the nature of division. If you could get a remainder of 6, then you could divide one more time. So we've got a number between 0 and 5. We want a number between 1 and 6. A quick and dirty way to do that is just to take that remainder that's between 0 and 5 and add 1 to it. Okay, so this line of code will create a variable called die, and it will set it to a random number between 1 and 6. Once that's done, we'll go ahead and type you roll the, and then the value of die, end our line. We return 0. Close our main function, and then save it. Okay, so to go over again, because this is really, this is the key right here for generating this dice roll. Remember I said, any positive number divided by 6 will give us a remainder between 0 and 5. To get this number between 1 and 6, we add 1 to the remainder. So to generate our die roll, we first generate a number between 0 and 32,767. Then we divide that random number by 6. We take the remainder of that division operation using our modulus operator and add 1 to it, and we store that remainder plus 1 in our die variable. That gives us a random number between 1 and 6. So let's go ahead and compile it. I left out something. In line 21. Oh. I forgot my semicolon. Never forget your semicolons. And let's go ahead and run that. Okay, that roll was a 3. That time was a 6, a 2, a 4, a 6, a 2, a 3, 5, 6, 1. That's random numbers.